Good evening everyone. I am thrilled to welcome you to this webinar on Cloud Native Development Skills Every Developer Must Master. I am Pranan Patil and I work as software engineer at ABC Trainings and I'll be your host today. So, as you all know that as cloud computing continues to reshape software architecture, cloud native development is becoming a must-have skill for every modern developer. In this session, we will explore the core concepts, practical tools, real-world projects, and future-ready skills needed to thrive in today's tech industry. So, firstly, I would like to make you familiar with what is cloud native development. So, let me introduce you to cloud native development. Cloud native development is about designing and deploying applications that take full advantage of cloud platforms. These apps are resilient, scalable, and agile by design. So, firstly, let me tell you what is cloud computing. So, we use cloud computing for storing large amount of data virtually. That is the data which we store in our PCs or laptops is stored physically. Physically means it has limitations or it has a specific amount of space. After that it will not be able to store the data. But in case of cloud computing, what happens that you can store large amount of data virtually. That is when you store data in your PCs or laptops, what happens that data occupies some bytes or some bits of your memory space. But in case of cloud computing, what happens that when you store data virtually, it does not occupy even a single byte or a single bit of space of your system. Okay. After that, now there are many cloud service providers or many cloud services like Azure, which is provided by Microsoft. Amazon Web Services, this cloud service is provided by Amazon. GCP, which stands for Google Cloud Platform, and this cloud service is provided by Google. In the same way, there are multiple cloud computing services which are provided by different service providers. Now, let me tell you how cloud computing works. So cloud computing means using remote servers hosted on internet to store, manage and process data rather than a local server or PC. Okay, that is using cloud computing. Using cloud computing, we store large amount of data on servers. We use large amount of data on servers. Let me tell you a simple example of this. For example, all of you must be using Chrome browser or Google Chrome browser. Now when you open the Google Chrome browser and search a specific search result, what happens in that case that when you search a specific query, what happens that Google Chrome browser displays multiple results related to that search query. But do you all know what happens at the back end? So what happens at the back end is that when you type a search query in the search box and after that hit the enter button, what happens that the search query is sent to the server of Google, and the search query which you have entered in the text box, data related to that which is stored in the server of Google is fetched and collected, and after that data is sent back to you, that is to the client, and search results or data related to that is presented to you on your screen. Okay, so when you need to store large amount of data, like I told the example of Google Chrome browser, so in that case you need servers, and you also need cloud computing, because physical memory storage devices are never enough to store large amount of data. Now the next point is cloud deployment. So many of you may ask that what is cloud deployment. So cloud deployment is the process of deploying applications, services or infrastructure to a cloud computing environment, and it involves configuring, managing and running workloads on cloud platforms such as AWS, Azure or Google Cloud. Okay, so that is that if you design a specific application or a specific server or a specific infrastructure, you need to deploy it. Like when you create a web application, what you do with it, that you host it. In the same way, when you create an application or a service and you need to deploy it using cloud storage. So that is known as cloud deployment, and that is you are hosting that application or service using a specific cloud service provider or a cloud service like AWS, GCP or Azure. So the next thing is that cloud computing is scalable. Now what is the meaning of scalable? So cloud computing is scalable, that is now let me tell you a simple example, but before that let me make you familiar with what is scalable. Scalable means the ability of a website to scale up when there is a load on that website, or to scale down during normal days. That is known as scalability. Let me explain you scalability through an example. So you all must be using e-commerce websites like Amazon, Flipkart, etc. So you all must be familiar with concepts like Black Friday sales, or concepts like when there is any special occasion, they introduce various offers. So whenever there are various offers or whenever there is a special occasion, what happens that on that day multiple users use that application more. That is because of offers, what they do, that they try to purchase a product at a very cheap price. So on that day the traffic on that website is more. That is millions of users or billions of users are using that e-commerce website or that e-commerce application at a time. In that case what happens, that the load on that website increases. So in that case what scalability does is that it scales up when the traffic is more, and it scales down when the traffic is less. That is, when more users are trying to access the website at a time, what it does, that it scales up automatically. And when there is no traffic, or when there are normal days, when there is no special occasion, on those days that e-commerce website scales down. Okay. So now next is resilience. What is resilience? That is, cloud native apps are built to recover quickly from failure. For example, Netflix uses chaos engineering to test how its services recover from random failures. So firstly, let me make you familiar with what is chaos engineering. So chaos engineering is practice of experimenting on a system by intentionally introducing faults like server crashes, latency, dropped packets, etc. to identify weakness and ensure the system can withstand turbulent conditions in production. So what is resilience? That, for example, services like or applications like Netflix, what they do, that they intentionally introduce a fault in their systems. That fault may be like server crash, or that fault may be latency, or that fault may be dropped packets, and they test the system that the system itself, without help of any other dependency, can it recover from that turbulent system or from that condition. They test it. Okay. So the next point is faster innovation. That is, cloud native promotes rapid development and deployment, reducing time to market significantly, as seen in companies like Spotify that deploy code changes thousands of times daily. That is, that is so. For example, as I mentioned the name Spotify, what they do that every day they update their code. That is, they make changes in their website. That is, every day according to their requirement or according to their business, what they do is they introduce new features. In their application, and in that case they need to manipulate the code. So every day they manipulate the code, and how what is role of cloud computing in that cloud native promotes rapid development. That is, whatever development they do or whatever modification they do, cloud native, what is role of it in that it adapts to it quickly. That is, the change whatever they do in their application is reflected within seconds in the application. So the next point is industrial needs and expectations. So today's businesses demand rapid time to market. Means companies must release updates frequently. Cloud native supports this through automation. The next one is elasticity. That is, services must adapt to fluctuating loads without human intervention. Uber's backend infrastructure scales based on user demand in different regions. That is, you all may be familiar with the Uber service, which we use for booking cabs. Okay, so what happens that Uber's backend infrastructure scales automatically. That is, it scales up when the traffic is more on that website, and it scales down automatically when the traffic is less on that website. That is, when multiple users are trying to use using the application at the same time. In that case, but obviously the load on that website is going to increase. So what cloud native's role is in this? That cloud native automatically scales it up when the load is more, and automatically scales it down during normal days or when the load is less. Next is fault tolerance. That is, systems must handle failure without service disruption. Google's cloud native systems use self-healing and distributed redundancy. That is, as I told a previous example, that what streaming sites like Netflix, okay, OTT platforms or streaming sites like Netflix, what they do, that is, they intentionally produce a fault like server crash or dropping packet or latency, and what they do with that is, they try to test whether this system automatically heals or automatically repairs itself from that fault or turbulence, and while automatically healing itself from that fault or turbulence, also the system works properly or not, or does it faces issues like server down or unable to access that website, etc. The next point is operational efficiency. Automation through CI and CD and monitoring reduces manual workload. Now, what is CI and CD? CI stands for continuous integration, and CD stands for continuous development. CI means continuous integration. Continuous integration means that what they do, that is, they keep testing the application or the service continuously, that whether all the functions of that application and the overall application, it works properly or not. And also continuous development. Now, what is continuous development? That is day to day, every day they keep updating their services, they keep updating the website. But if you have deployed your that application or service on a cloud computing platform, like it may be AWS, Azure or GCP, then what is the role of cloud computing in that, or that particular cloud computing service, that it adapts to that change rapidly. It adapts to that change rapidly, which reduces manual workload. After that, cloud agnosticism. Firstly, let me tell you what is cloud agnosticism. So, cloud agnosticism refers to design philosophy of building applications and system in such a way that they are not dependent on any single cloud provider like AWS, Azure or GCP. So, as I told, that what is cloud agnosticism, that the system which you are going to deploy, or the application which you are going to deploy, it must not depend on a single service. That is for example, if you have designed the application, or if you have designed the service, and you have designed it in such a way that you can deploy it only on AWS, or you can deploy it only on Azure, then it's of no use. Because when you are unable to use these services, may it be AWS or may it be Azure, in that case, if you want to keep your application still running, and so for that you need to use any other cloud computing services. So while designing your application, you need to take care of this thing, or you must keep this thing in mind, that your application must be compatible with any cloud computing service, may it be GCP, Azure or AWS. That is, if one cloud computing service is down, or it's not working, or it's temporarily shut down, you must be able to deploy your that application on any other cloud computing service, may it be GCP, Azure or Amazon Web Services. So, next one is multi-cloud and hybrid cloud support. Now, what is multi-cloud? So, in cloud also there are many types. There are types like public cloud, private cloud, etc. Now, what is hybrid cloud? Hybrid cloud can be called as combination of two clouds. For example, private cloud and public cloud. Okay. And now, what is multi-cloud? Multi-cloud can be said as that. For example, if you are using two cloud services at a time, it is also known as multi-cloud. Now, the next slide is about core concepts of cloud native. So let's look at the functional building blocks. First one is microservices architecture. That is, it breaks applications into small manageable services that communicate via APIs. Amazon transitioned from a monolithic architecture to microservices to scale globally. The next point is containers, Docker, that is package applications and their dependencies for consistent behavior across environments. Adobe uses Docker to streamline development and testing environments. The next point is orchestration, that is Kubernetes. It automates deployment, scaling and management of containerized applications. Spotify uses Kubernetes to manage large-scale deployments. The next point is CI and CD pipelines, that is continuous integration and continuous development pipelines. What they do, that is they automate code integration, testing and delivery. Facebook implements robust CI and CD pipelines for continuous updates. For continuous updates means continuous integration. As I told you previously, that what is the meaning of continuous integration? That is you keep testing your application continuously. That is whether all the functionalities of your application are working properly or not, or whether your overall application is working properly or not, or is it facing any issue, or is there any problem in any functionality or in any design or in any feature. And what is continuous development? That is you keep updating that specific application or that service daily. That is, daily you introduce new features, you add new features in it, or you remove some features which are of no use no more. Okay, that is known as continuous development. That is you keep updating your application daily. That is, you may remove some features or you may add some new features. So in that case cloud native helps your application or supports your application to rapidly adapt that change, okay, or to adapt that change. So the next point is DevOps and GitOps. So what is DevOps? DevOps refers to development operations. Okay. So what it does, that it facilitates collaboration between development and operations. GitHub Actions and Argo CD enable declarative infrastructure updates using Git repositories. The next point is observability. That is, it collects logs, metrics, and traces for debugging and performance. Prometheus and Grafana are used at companies like Red Hat for monitoring microservices. Now, what is observability? That is it monitors the application. It collects logs, metrics, and traces. That is if there are any issues, or if the application feels like at this point there is any issue, or our application is lagging this any specific feature or that any specific feature. In that case, or if there is any issue in any functionality or in any feature, then what observability does is that it collects those logs or it collects those errors and it sends it to the debugging team, and what debugging team does is it works on those issues and resolves those issues. But if they are not able to resolve that issue, what they do is they remove that feature, and instead of that they introduce a new feature with more updated skills in it or with more updated options in it. Now, the next point is must have developer skills. So to succeed in cloud native roles, developers need containerization, that is Docker and Podman, and both of these are used to create and manage containers that run reliably across environments. After that, the next point is orchestration, that is Kubernetes and Helm. So Kubernetes handles containers or container orchestration, that is Helm simplifies deployment of complex applications. For example, IBM uses Helm charts for deploying microservices. So the next point is DevOps tools, that is Jenkins, GitHub Actions, and Argo CD. After that, there are some CI and CD tools like Jenkins, GitHub Actions, and Argo CD, which enable continuous integration and delivery. GitHub's internal development leverages these for fast deployment cycles. After that, infrastructure as code. In short, we can say that IAC. So tools like Terraform and Pulumi automate infrastructure provisioning. Spotify uses Terraform to manage cloud infrastructure reproducibly. After that, the next point is cloud providers, that is cloud platforms. So you must be familiar with AWS, Azure, or GCP. So Netflix heavily utilizes AWS services for its global streaming infrastructure. After that, programming languages you must know. Those are Go for system level programming, Python for automation and data, Java for enterprise grade backends. Now, Python for automation and data means in this case you are going to use Python for development as well as testing. Many of you must not be knowing, but we use Python for software development as well as web development. That is, it can be used as scripting language also, as well as for testing. Means for software testing. That is, in other words, you can say that test automation. And we use Java for enterprise grade backends. After that, secure API design. That is, we use REST and GraphQL protocols, authorization 2 for authorization, Stripe's payment APIs are examples of secure and scalable REST APIs. Now the next point is let me tell you one project example which is of employee management system. Its front end is designed using Angular framework, while its backend is designed using Spring Boot plus Hibernate. And for database, we have used MySQL. Okay, in that, why we have used cloud native enhancements, or what is role of cloud native? That is, Docker images were created for front end and back end services. Sorry. Kubernetes orchestrated service deployment across pods. After that, GitHub Actions automated build and deployment pipelines. Prometheus scrapped metrics while Grafana visualized them, and we hosted this employee management system application on AWS using Elastic Kubernetes services. That is, in short, we can say EKS. So after that, the next slide is about software stack required. That is, we require integrated development environment and tools like VS Code for lightweight development, IntelliJ IDEA for Java, Postman for API testing. After that, we require containers, that is Docker desktop, to build, run and debug containerized applications. After that, there is orchestration, that is Minikube simulates a local Kubernetes cluster, while kubectl is used for management. The next one is CI and CD, that is continuous integration and continuous development. So we use Jenkins for pipelines, GitHub for version control and workflow automation. After that, next one is monitoring, that is Prometheus for metrics, Grafana for visualization dashboards, and lastly, cloud platforms like AWS free tier or Azure student credits allow low cost experimentation. So now let me make you familiar with real world use cases of cloud native development. So big tech companies that use cloud native architecture are Netflix. Netflix uses it for microservices deployed in Docker containers managed by Spinnaker and Kubernetes. After that, Spotify uses it for leverages Kubernetes and Terraform for infrastructure and monitoring with Google Cloud tools. Uber uses it to handle massive amounts of real-time data using cloud native messaging, queues and service meshes. And Amazon, what Amazon does is Amazon operates millions of services across different zones using cloud native design patterns for high availability. Now the next slide is about learning path for beginners. So the learning path for beginners is, here's how you can start your cloud native journey. First one is understand cloud basics, that is learn cloud models like IaaS or PaaS or SaaS. Then the next one is grasp DevOps principles, that is understand CI and CD version control automation. After that, the next point is learn Docker, that is create, run and manage containers locally. After that, also make yourself familiar with Kubernetes, that is learn architecture, pods, deployments and services. After that, build a simple project, containerize and deploy a microservice. Then set up CI and CD, that is automate deployment with GitHub Actions. Then monitor your application, that is use Prometheus and Grafana to view performance metrics. And lastly, focus on security, that is implement API security, access policies and secure configurations. So final takeaways from this session are that cloud native is the new standard for resilient and scalable applications. Cross-functional skills are vital, that is code plus cloud plus automation. So I would like to say that start with small, meaningful projects and iterate. Practice continuously with real-world deployments. Use community tools, contribute to open source, and stay updated through DevOps, blogs, and GitHub repositories. So I would like to tell that cloud computing is the latest emerging trend in the tech world, and it's going to increase rapidly in the upcoming future. So I would suggest that cloud computing is also a great opportunity or a great skill to learn, and you can also make a great career out of it. So we at ABC Trainings welcome you, and we also provide cloud computing course, and I welcome you, and we also provide you cloud computing course, and please start with us and make yourself familiar with cloud computing services and cloud computing technology, and you will also be able to land a job of 6 LPA to 12 LPA as a cloud computing engineer at any MNC according to their requirements. So I hope this session was useful for you, and you may have learned some good things from it, and it may be helpful for you in your future. So thank you for listening to me patiently. Let's meet during the next session.